In this video, we want to show you the new features that help to improve process stability. We want to show you with this demonstration. Some of you may have already seen. In this demonstration, we are inspecting several PCBs with a deep learning approach. The technique behind is called global context anomaly detection, and it's really doing a good job. But today this is not the topic. Today we want to show you the new features that are all related to image acquisition. So just for your information, over here we have this rotary wheel with several PCBs. And when the PCB is in the correct position, a trigger is sent. And of course what's happening then, an image is acquired and the image is sent to MERLIC, where all the image processing is happening. So now let's have a look into MERLIC. So here on the screen, you see on the left side is the MERLIC front end. You can see the new acquired images and the image processing results. You can see this overlay where any kind of anomalies are shown. And on the right side, we show you the web app example of the REST plugin. We just use it for demonstration purposes because it shows some statistics. Here what you can see now is our state machine. This is very important for the process integration. And now we're here in the process state ready. From here we will start the continuous execution, which I'm doing now. So now you see images are acquired and the image processing is performed over here. Here on the top you see the results category. Down here we see for every trigger that came in, we see one result ID together with the result state. You see over here the result is completed, and over here you see some result values like the anomaly detected or anomaly score, and then some other statistic like process time and time step. Over here in this category you will see some errors, but currently the list is of course empty. So now what is our first feature? Our first feature is called dropped images detection. As the name already states, this will indicate if an image is dropped during image acquisition. It works as follows. Every acquired image comes with a frame ID that is increased for every image. So we can easily count and also track these images. So now let's assume we have a problem during image acquisition and images might be dropped, then we are able to detect this. We can demonstrate this by increasing the speed of our rotation plate. Give me a second. I'm increasing the speed now. You can see that the image acquisition is happening faster. And on the right side, we see a bunch of errors. So we stop the execution. Okay, now let's have a look in detail. So there's a lot of error code 64 coming in. There's also an explanation what this error means. An exposed frame has been dropped. This may happen if the camera is consistently triggered faster than frames are processed. And in details, it says, acquired image camera demo failed. The image with frame ID 229 has been dropped. The next available image has been frame ID 230. So you see one image was lost, it was dropped, but the next frame was detected. So we know, okay, there was a problem. Okay, now let's have a look in the results category. Here I told you for every trigger we have a result with a result ID, and usually we have results with the completed result state, but here there are several with a failed result state. These were the ones where the acquisition failed and when there was an error detected. Yeah. So with the new feature, dropped images detection, it's now possible to detect these errors. Now let's come to the next feature, camera connection observation in ready state. Let's assume you have problems with a camera connection and a camera is disconnected. Usually you won't find this out just until a camera acquisition is triggered. What we now additionally introduced is the observation of the camera connection when the process is in the ready state. So what you see now, from the state machine, we are in the ready state and no image acquisition is performed. Now let's simulate a communication error. So we are unplugging the cable now. In 3, 2, 1, 0. Now the cable to the camera is plugged off, and here immediately one error occurred. It's error with the error code 21, and I will read it to you. The connection to the image acquisition device has been lost. And in details, there's a bigger text. I will read it to you. The acquisition device for image source camera demo is no longer connected. As a consequence, MERLIC RTE changed to the error state. You can try to resolve the problem using the image sources tab of the MERLIC RTE setup. Once you're done, close the MERLIC RTE setup to trigger a re-evaluation of the configuration. If it is found to be working again, MERLIC RTE will return to the ready state, otherwise it will remain in error. Okay, so this message is also sent to the PLC, so that you know what needs to be done. Over here, the state machine changed to the error state. So what do you have to do now? You have to reconnect the camera again, or maybe you have to find also the error. Maybe you have to change the defect cable with a new one. And then when the camera is reconnected, you can go on with the image processing.